which notation represents hydrogen isotope. So the key word here is isotope. So isotope indicate that they have the same atomic number, the number of proton, and different mass number. So in this case, you want to look at the bottom number first to see which one you can eliminate. For those that don't have the same bottom number or the number of proton, we can eliminate them. So 1 has the same, 2 has different, so we can eliminate it. 3 have different, so we can eliminate it, and 4 have different, so we can eliminate it. So by elimination, we can then identify that the correct answer is this one. So this problem is calculating the atomic mass, okay? And when you calculate the atomic mass, you're going to take the mass of the isotope and multiply it by the weighted average, or how much percentage we have for each one, and then add them up. So in this case, we have two isotopes, gallium-69 and gallium-71. So gallium-69 has an atomic mass of 68.93, and gallium-71 have an atomic mass of 70.92. Now, how much of the gallium-69 do we have? Well, we have 60.11%, but we don't write it as percentage. We want to convert it to decimal. And how much of the gallium-71 do we have? Well, we have 39.89%. So again, we're going to write that as decimal. And then when we multiply them out, we will add them all up together, okay? So this is now an addition problem. So if we take a look at this, we can eliminate the division problem. And we can eliminate this division problem. And we can take a look at the two remaining one. And in the two remaining one, we have to write it as a decimal. And so this would be the right answer. So in this question, what we want to look at is we want to see what represent nonmetal. So the key word here is being nonmetal. So nonmetal, remember, is to the right of these steps. It does not include the one that sits on top. These are metalloids, okay? And so we want to talk about those that go this way. Okay, so therefore, we have B. B is here, and so B sit on the step, so we know that can't be. Yeah, so we're going to eliminate that. And then we saw that we have C's, SI, and GE, and SI sit on the step, so we're going to eliminate that. Then we saw LI, where LI is all the way over here toward the metal side, so we're going to eliminate that. And so the only thing that remains is answer number 4. So in this problem, what we're looking for is what this symbol X stands for. Okay, and so we have the formula XSO4. So we know there's 3 elements, so there has to be a polyatomic element. And since we want to know what X is, we're going to assume then that we are grouping SO4. So we can go take a look at the polyatomic ion, which is table E. And we find that SO4 actually has a -2 charge. So we're going to write a -2 charge up here. So with that -2 charge, we know that there's one SO4, so therefore that is a -2 down here. And we're going to equal that. So in order to make this balance, this side has to be a +2 charge. So a +2 charge is part of group 2. So therefore group 2, we know that 3 magnesium is the only one that's on group 2. So in this one, we are looking to see how to write the formula for lead 4 oxide. So let's first write off lead is Pb. We know the oxide is O. We know oxygen always have a -2 charge. And since this is lead 4, that will make it a +4 charge. So we're going to cross over. We're going to bring this 2 down and this 4 down. And so now we have PB204. And so let's reduce this by a common factor, and our common factor here is going to be PB02. And so our answer, therefore, is 1. So in this question, we want to know what is the trend for electronegativity and atomic radius as we go across period 2. So electronegativity and atomic radius. Well, first of all, let's draw out the table that I asked you to do, and that is the table, the periodic table. And I ask you to remember that atomic radius, as it goes down a group, the atomic radius is going to increase. And so, therefore, the atomic radius, as it goes across a period, it is actually going to decrease. So the reverse is true for electronegativity and first ionization energy. So we know that as we go down a group, the electronegativity is going to decrease. As we go across a period, the electronegativity is actually going to increase. So we know that atomic radius and electronegativity are opposite each other, and that electronegativity as it go across will increase, and atomic radius will do the opposite. And so the only thing that meet this criteria is electronegativity increases and atomic radius decreases. So that's answer number 3. So in this one, we want to calculate the percent composition, okay, by mass of nitrogen. So we are already given the fact that the atomic mass, the grand formula mass for this compound is 96.0 gram. Well, we know that we have a nitrogen, and there's 2 of them. So nitrogen is equal to 2 times 14. 14 get from the periodic table, and that gives us 28 gram per mole. So therefore, we're going to put 28 gram per mole over 96 gram per mole. And that is going to give us a 29.2%. So that is going to give us answer number 2. So in this problem, we are looking at the equation that is given right here. And we are trying to determine what our chemical reaction that represents. So what we can see here is that we have a compound, and then we have an element, and they switch places. So therefore, when you have a compound and element that switch places, that is definitely a single replacement. That is a definition question. So in this problem, we are looking at a nonpolar molecule and that contain polar covalent bond. So first of all, we're going to eliminate anything that is not a nonpolar molecule. Now, nonpolar molecule is a symmetrical molecule. That means that when you divide it up in half, both sides will look the same. So in this case, the only one of these, well, let's take a look. Is that number 1 is symmetrical? Yes. Number 2 symmetrical? Yes. Number 3 symmetrical? No. So number 3 is not it. Number 4 symmetrical? No. So between 1 and 2, both of them are a nonpolar molecule. However, remember the question also said it must contain polar covalent bond. A polar covalent bond is a bond in which the electrical negativity differences has to be greater than 0.4, 0.5. So in this case, we know that in question number 1, in chemical bond number 1, H and H, well, both of them have the same electronegativity, so it can be 0. So therefore, there's no way it can be a polar covalent bond. So by elimination, the only possible answer is number 2. So in this equation, we are asked to look at these 2 graphs, and we want to know what is happening in this so that it's at equilibrium. So, well, equilibrium is when the forward reaction and the reverse reaction are the same, or are we saying is constant. So therefore, the answer has to be 3.